line of code in FFmpeg had been tested 5 million times by automated tools. 5 million runs, years of human review, countless security audit. Nobody found it. Then Anthropic ran one AI model through it, and within hours, it found a vulnerability that had been hiding there for 16 years. That same model found a 27-year-old flaw in OpenBSD, an operating system built specifically around security. And it didn't just find the bug, it wrote the exploit autonomously. No human involved after the first prompt. I'm a QA engineer and I have spent 13 years believing that if you build enough tests, run enough tools, the system will be safe. That belief just got broken. This is the story of Claude Mythos. How it leaked, what it can do, and the QA question our entire profession is not ready to answer. Let me give you the context because this story has layers. Anthropic, the company whose entire brand is built on AI safety, has spent the last 2 years building something they were afraid to release. A model so capable in cybersecurity that they wrote internally it can exploit vulnerabilities in a way that far outpaces the efforts of defenders. Read that again. They built it, they're scared of it, and they rewrote that sentence in a document they accidentally left in a publicly searchable data store. In late March 2026, a misconfiguration in Anthropic's content management system left nearly 3,000 internal files publicly accessible. Among them was a draft blog post announcing a model they had not told anyone about, internally called Capybara, publicly named Claude Mythos. Security researchers Roy Paz and Alexander Powells found it. Fortune reviewed the documents. Anthropic confirmed it was real and pulled public access. Here is what the leaked documents and Anthropic's own Red team report. Claude Mythos has found thousands of high-severity zero-day vulnerabilities across every major operating system. And not hypothetical vulnerabilities, real ones that are now being patched. The OpenBSD bug is the clearest example of why this all matters. OpenBSD has a reputation as one of the most security-hardened operating systems ever built. It runs firewalls, it runs critical interests. Security is not an afterthought. It's the entire point. And yet, Mythos found a flaw in its TCP stack that had been there since 1998. A 27-year-old bug, 2 carefully crafted packets, and any OpenBSD machine connected to the internet could be crashed remotely. Human auditors had reviewed that code. Automated tools had run against it. None of them were able to find it ever. Then there is FFmpeg. If you have ever watched a video online, YouTube, Discord, VLC, FFmpeg was probably involved. It is one of the most tested pieces of software in existence. Security research have literally written academic papers on how to fuzz it effectively. That particular vulnerable line of code had been hit by automated testing tools 5 million times. Mark it, 5 million. Nobody caught it. Mythos found it because it didn't fuzz. It read the code, it understood the logic, it reasoned about what would happen if a video file had exactly 65,536 slices, one more than the maximum value of the marker being used to track it. And it was right. Anthropic announced Project Glasswing alongside the model. 40 organizations, namely AWS, Apple, Google, Microsoft, CrowdStrike, JP Morgan Chase, NVIDIA, all have early access to Mythos preview specifically to scan their system and patch vulnerabilities before this level of capability becomes widely available. The company is committing $4 million to open source security foundations to help maintainers handle what's coming. Here is what is coming. Anthropic's own assessment says that over 99% of the vulnerabilities Mythos has found have not yet been patched. The full Glasswing public report drops in July 2026. When it does, it will trigger a patch cycle across every major operating system, browser and cryptography libraries simultaneously. Security teams that are already understaffed will not be able to handle this. They cannot work through fast enough, and the clock doesn't stop while they try. Now think about what else sits in this ecosystem. 2 weeks before the Mythos leak, a completely separate incident, Anthropic accidentally published file like 12,000 lines of Claude Code source code to NPM. The package included a 59.8 megabyte debug file, one line missing from a config file, the entire code base public for 23 minutes before a researcher spotted it. Inside that source code was KAIROS, an unreleased autonomous agent mode for Claude Code that doesn't wait for you to give it a task. It runs in the background, it watches your GitHub repositories via webhooks. While your laptop is closed, while you're asleep, it decides on its own when to act. It has a feature called Auto Dream. While you are idle, it performs memory consolidation on everything it has observed, cleaning its own context, getting ready for when you return. That feature has not shipped yet, but it will. There was also an undercover mode, a feature that automatically strips the AI attribution from Git commits when Anthropic employees use Claude Code to contribute to external repositories. It prevents the AI from mentioning unreleased models. Anthropic built a tool specifically to stop secrets leaking through code contribution, and then they leaked the code base that contained it. These are two separate incidents. One company, 6 weeks apart. The company is now telling 40 of the world's largest technology firms to trust its most powerful model with their most critical security infrastructure. That tension is where this story breaks. For 13 years, I have been the final gatekeeper. That's how QA engineers think of themselves. The human in the loop. The person who reads a pull request before it gets merged. Who runs the test suite before it ships. Who signs off before production. We are the last check before the code touches the real world. Mythos doesn't need a gatekeeper at all. In Anthropic's own red team testing, they gave the model a prompt, they launched an isolated container running a target code base, and then they stepped back. No human guidance after that. Mythos read the code, formed the hypothesis, tested them, found vulnerabilities, chained them together, and wrote working exploits. Autonomously in some cases, that too overnight. Mythos didn't find bug. It found several low-severity issues that individually meant nothing, the kind of things that would pass a code review, pass a security scan, get merged without concern. Then it combined them. Bug 1 let it figure out where things were in memory. Bug 2 let it read a protected structure. Bug 3 let it write to memory. Bug 4 placed a malicious object exactly where that write landed. Full root access. Every one of those bugs would have passed my review. Together, they hand over the machine. The gatekeeper is not being replaced. The gatekeeper is completely getting bypassed. So what do you actually do with this? First, stop treating your testing pipeline as a safety net and start treating it as a snapshot in time. If your security posture assumes that because the test ran and nothing failed, nothing is going to be wrong, that assumption just expired. Your pipeline needs AI-assisted vulnerability analysis, not just automated fuzzing. Second, shorten your batch cycles. Treat CVE tag dependency updates as urgent, not routine. The window between a vulnerability being discovered and it being exploited is closing faster than it ever has. Third, learn to audit autonomous judgment, not just code output. When a model chains 4 low-severity bugs into a privilege escalation, no individual bug tripped a rule. The danger was in the combination. That's the new QA problem. Not does this function work, but what does this system do when it decides to try everything it knows? Anthropic spent 2 years building a model they were afraid to release. They formed a consortium of 40 companies to use it only for defense. And then, in the same 6-week window, they left 3,000 internal files in a public data store and accidentally published the source code of their most important product. The company building the AI safety brand could not secure its own CMS settings. The question QA engineers need to start answering is, not can the AI find bugs, it clearly can. The question is, when the AI finds a bug at 3 a.m. in the morning and no human approved the fix, how do we know the fix didn't introduce something worse? We don't have a framework for that yet. That's a frontier, and that's our job. The blueprints are out, the capability is real, and the era of human-only gatekeeping is ending whether we are ready or not. If you are a QA engineer figuring out what AI needs for your career, subscribe. I'm Samaj, having 13 plus years of experience in QA across banking and fintech. I test these tools, I track the leaks, and I report back honestly so you don't have to figure it out all alone. Subscribe for more.